Welcome to this video on significance tests for slope. By the end of this video, you should be able to perform a significance test about the slope of a population regression line, and we'll be using the four-step process. Alright, so a teacher, Mrs. Gallus, is wondering if there's a relationship between GPA and ACT scores. She took a random sample of 9 out of her 101 students and recorded their GPA and ACT scores. Here is your data below. So the first line, the student number, it's not actually part of the data, it's just showing, it looks like she randomly assigned, she gave them numbers and then randomly picked them based off the numbers. So we have our GPA and our ACT. So take a second. What relationship would you expect GPA and ACT score to have? Pause the video, answer the question, and come back when you're ready. I would really expect a positive linear relationship, because I would really expect if your GPA is higher that you would have a higher ACT score. So I feel like this would be a positive relationship, but we're going to take a look at this. So here's the Minitab output of the data. So remember, the Minitab is just one of the programs that gives you the data. They all look similar, they're all a little bit different, but what they all have in common is there'll be the word constant, and you'll have a coefficient. The constant, remember, is your y-intercept, so that's A when you're going to write your regression equation. Whatever's below it, this is our x value really, that's our slope. So there's our slope. The other thing that you are going to need is the standard deviation of the slope. So this guy right here, it's on the slope line. So it's the standard error because it came from a sample, the standard error of the slope. Okay, and then remember this is a t-score. And this is a p-value for a two-sided test. So if we're only doing a one-sided test, you would have to divide it in half. Okay, so we have a lot of information, and they very generously gave us the graphs for us to look at, because we're going to need to refer to these graphs in our conditions. So the first question is, find the equation of the least square regression line. Okay, so I like to use context here. We will be predicting the ACT score. So when we're in this form, GPA is the x value, ACT is the y value. So your y-hat is actually going to be your ACT score. I'll put a hat over it, equals A, which is 1.201 that we got above, and then B plus or minus B. What is it's a positive, so plus 7.507. X would normally go here, but X refers to your GPA, so we'll write GPA in. So here's the equation of our least square regression line. Now we're going to take it and we're going to start doing a four-step process on the back of this. So do these data provide significant evidence that there's a positive linear relationship between GPA and ACT? So our parameter, we're talking about slope here, so we're going to say that beta is going to represent the true slope of the population least square regression line. For GPA, which is our x, and ACT, which is our y. Okay, our statistic is our slope, and we got 7.507 for our slope. Now our null hypothesis, we discussed this on the very first day, so our beta is going to be 0, and what that means is there is no linear relationship. Okay, so by saying 0, they were saying there's no linear relationship. if and so that's our null. Our alternative, we want to look, it says we want to know if there's a positive linear relationship. So that would mean our beta would be greater than 0. If we had wondered about a negative linear relationship, our beta would have been less than 0. So beta greater than 0 says this is a positive linear relationship. Okay, so our significance level, it doesn't say, so we're going to use an alpha 0.05. Okay, now the name of the procedure, this is a one sample. It's going to be a t-test for slope. Okay, we're going to check our conditions. So remember, the regression inference has 5 conditions that have to be checked. And you can use the mnemonic liner from the previous lesson to help you remember everything. Now, we are lucky because we were given all the graphs that we need. We don't have to generate them ourselves. So the linear portion wants you to take a look at the scatter plot and the residual plot. Okay, and so when we look at the scatter plot, it's fairly linear. Okay, so that's what we're going to say, is that our scatter plot is fairly linear. There's an ly word to kind of, we don't want to say it is linear. It looks pretty linear. You want to be a little wishy-washy on that language. And the residuals, so when we look at the residual plot, there's not a distinct curved pattern. We have x values above and below. This is below, this is above and below. So it's not everybody's above, everybody's below, everybody's above, or anything like that. We don't see that curved pattern. It's a little more scattered. So that's what we're going to say here, is that the residual plot has no leftover pattern. Okay, so you're saying I looked at this. This does appear to be linear. Okay, the next one we want to look at is your independent. We had a sample of 9, and they told us of 101 students, and 9 is less than or equal to 1/10 of 101 students. So we're good there. Okay, now our normal, you want to look at the dot plot of the residuals. Okay, so here's our dot plot of our residuals. And from a center, we have like 4 on this side. We also have 4 on this side. Maybe this is a residual, outlier. But it's kind of even. It's not really skewed. I don't have all of them over here and just this guy over here. So we're going to say that it appears to not be strongly skewed or have any outliers. So for our normal, dot plot of residuals appears to have no strong skew or outliers. Okay. Then the next one, equal standard deviation. Remember, is your residual plot about equal from the x-axis. You don't have a pattern like similar to a Christmas tree where you're back and forth if you looked at it sideways. So looking at a residual plot, let's kind of look at it this way. So really, between -4 and +4, most of the dots are in this area. We have a pretty equal standard deviation of these residuals from the x-axis. So what we say is that our residual plot shows a similar variability for each x value. They're all about the same distance from the x-axis is really what we're saying here. And then our last one is, it did say, this is random, so it was a random sample of 9 students. Okay. Now, the general formula for a test statistic, whenever you're doing a test, you need a test statistic, is you're going to take your statistic minus your parameter and divide it by the standard deviation. So what that looks like specifically here is we're going to be using a t. We're getting a t statistic, and your statistic will be the slope of the regression line of your sample minus beta divided by the standard error of the slope. Okay, so let's plug in everything that we've got into this formula. Our beta was our slope of our regression line of our sample was 7.507. Beta is 0. That was our null hypothesis, minus 0, divided by, well, now we need the standard error of the slope. So we got to flip it back over, and the standard error of my slope was 1.29. Okay, so we're going to plug in 1.29. And we're going to calculate this out, and we're going to get 5.819. Okay, now that's our t, so that would round to 5.82 with 2 decimals. Remember what I said on the front. There's a lot of back and forth here. It's t-score. There it is, 5.82. Okay, but you got to show all your work. You can't just say it's in the chart. So now the picture. So we'll have our normal curve, because we said normal back over here. That's what we were going for. It's going to center at 0. And the standard error is 1.29. Okay. And so we have 2 things going on. So it's going to be 0 because that was our beta. And we had a slope of 7.507, and we want to know the likelihood of being that far or more extreme. Also, when you take a test statistic, you center at 0, and I got a t-score of 5.82. Alright, so let me show you 2 ways to get the score here. So we worked this out, and we got a test statistic of 5.82. To get the p-value, we can look in the t-table, which is table B. So our degree of freedom here was 9 minus 2, because remember it's n minus 2, so we have a degree of freedom of 7. So on line 7, we want to go across until we find 5.82, so that's going to actually be off this edge right over here. So that all we know is that our p-value is less than 0.0005. So by the table, our p-value is less than 0.0005. Let me show you how to do this in the calculator. In the calculator, we're going to go and look at the tests. So stat over to tests, and you're going to want, if you go up, it's going to be a lot faster. We want the lin-reg t-test. We can do the interval like we did in the previous lesson, can also be done in the calculator. So when you go to the LinReg t-test, it wants you to put the x's into list 1 and the y's into list 2. So you're going to go into Stat, Edit, and you're going to put your GPA in list 1 and your ACT score in list 2. Once you have that in there, you're going to run your test, list 1, list 2, and our null is that it equals 0, but our alternative is that we have a positive, so we want to make sure we pick the greater than 0 and press calculate. So it gives us a whole lot of information, but what we're looking for is our p-value right here is at 3.2555 to the negative 4. So by the calculator, you got 0.000326 when you rounded it out. Okay. Now remember, on the other side, we're going to flip this back over again. I told you that this was our p-value for a two-sided test. If you take that number and divide it by 2, because we only did a one-sided test, you will get what we got for our p-value. Okay, but you still have to have all of this information in order to get full points. So what I want you to do is I want you to pause the video and write your conclusion. Make sure you interpret the p-value. That's the assuming there is no linear relationship statement. Make your decision about the null, and then a conclusion about your alternative, and come back once you're done. All right, so your full conclusion, assuming there is no linear relationship between GPA and ACT scores true, there is a 0.000326 probability of getting a slope of 7.507 or greater purely by chance. Because 0.000326 is less than 0.05, we will reject the null. We have convincing evidence of a positive linear relationship between GPA and ACT score. So when we write our test conclusions, you need to have your 3 important parts. This whole beginning part where we're assuming the null is true and talking about the probability of getting what you got purely by chance. That's where we interpret the p-value. Okay. So then we interpreted the p-value. We need to make a decision about our null. Okay, and then we follow that up. So if we're going to reject the null, what does that mean for the alternative? So you have a conclusion about your alternative. Those 3 pieces need to be in every one of your test conclusions. All right, let's summarize this. Go ahead and flip it over and we'll get everything that needs to be in your 4-step significance test. So for our significance test for slope, our 4-step process, in our state, we're going to need to define our parameter, which is beta, which is the true slope of the population regression line, least square regression line for the population, and then you want to say your x context and your y context there. Okay, so once you've defined your parameter, that will also be used in your conclusion, so it's nice to have. You need to write your null hypothesis. The null hypothesis is that the population has 0 linear relationship. So this means no linear relationship. And your alternative is either going to be that beta is greater than 0, which means a positive linear relationship, beta is less than 0, which will be a negative linear relationship, or beta does not equal 0, which just means it's something else. Okay, so that's our state. Also, as always, make sure you write your alpha level. For our plan, our procedure is a one sample t-test for slope. And then you had the four things that you need to, the 5 things you need to check. It only happens for regression. For these, make sure, go back and look at seat location part 2. To get all the information on that. For our do, you'll want to draw a picture and shade. It's going to be centered on 0. It's going to be a normal curve with the mean of 0 and a standard error of the slope that you'll get from the Minitab output, or will be told it. You need to have your formula, which is going to be your t-test statistic is going to be the slope of your sample regression line minus beta divided by the standard error of the slope. Remember that your degree of freedoms is n minus 2, so you want to include your, and really you can just put it up here. Okay. That should be everything you need for that. And then in your conclude section, you need to interpret your p-value. You need to make a decision about the null. And then you need to make a conclusion about the alternative. All right, so in your scenario, we revisit the ears growing throughout your lifetime. There's a Minitab output here. So this is age versus ear height. So the age was the x value, the ear height was the y value. Constant, remember, is your y-intercept. Below it is always the slope, so the number down here is slope. We had standard deviation of the residuals right there. You've got the standard error of the y-intercept and the slope, but what you will be using is the standard error of the slope. Remember, under t here, that's your t-score, so you still have to work it all out. This is your p-value for a two-sided test. If you're not doing a two-sided test, you will have to divide by 2 for a one-sided test. Okay, so all the work still needs to be there, even though you can get the numbers from here up here. I would use these as verification that you've done everything correctly versus just taking them. You want to make sure you set everything up right. All right, check Canvas for the answer key to your Check Your Understanding. Let me know if you have any questions. See you in class.